you. It's Mark Miller, Fred, my co-host over there. My other co-host is Rory.
Hello.
How you doing, Rory?
I'm good. How are you?
I'm like, okay, I'm still fighting something. I don't know what I'm fighting, but I'm fighting
that's not good.
something. You know, a little bit like in the chest. I don't think it's the COVID because nobody else is getting sick. But I'm definitely fighting something, and it has to do with
You're winning, but not as quickly as you'd like to.
Right, what I'm breathing. Yeah, so that's kind of what's going on here. We'll just see this. Let's get rid of that. And this is a weird error. I don't know why I get this. I haven't looked this up yet, but I get this on classes that are actually being used. Physics is defined but never used. I can hit the tab key, tab to next reference using CodeRush. It's used, you know.
It is.
Hold on, I got a bunch of this going
Quite
on
a lot.
Yeah, let's. I've kind of made it a kind of a thing that I do now. If I see issues here, I correct them. Right, if I see these, so just the idea that I'm gradually cleaning up the code. You know, as I
got a couple of smaller TypeScript projects that I mess around with on sort of spare moments and things, and it's gone a slightly different way. I've got a combination of modules and/or namespaces just due to legacy reasons. And in certain situations, I find myself needing to use an export keyword in order to make the file function, the object, as it were, available outside of this file. I wonder if the TS-lint or the whichever linting it is not aware that your settings allow for your classes to be available without an export, and therefore they're assuming that they're only used in this file. Therefore, if not used in this file, not used at all.
Yes, I agree with that. That sounds certainly like a possibility. Hold on a second. We just saw Codebase Alpha come in, and
we did, and there was nothing to accompany his entrance.
We had a shutdown just before we started here. Let's close and restart our pieces here that are supporting us. Hold on a second. Let me get those. What is going on? Why can't I'm hitting Alt F4. Is it function lock? No. I'm hitting Alt F4 to close the window, and it's not closing the window. Just so you can see what I'm doing, this is what I'm hitting Alt F4 in PowerShell. Alt F4, that's really weird. I hit function lock, try to hit it again. This is something I'm pretty sure worked before. Killing that. Let's also kill this one. We're going to reconnect this piece as well. So yeah, we had an unexpected restart of OBS. So let's go start those two supporting apps with the bots. There's one. There is number 2, and I have a test that I do. I fly around a drone. Let's see if that works. Drone is not coming up, but you know what? I need to now refresh the overlay. So let's refresh all the overlays so they can reconnect with their signal R. And
there's mine. My drone is here.
All right. There we go. And mine's out there. Let's refresh the data. And now this needs to be restarted as well. Everything needs to be restarted. Because once you shut something down that's got signal R in it, the other pieces that were connected appear to no longer be connected anymore. All right, I'm starting that up, and that app will start, and we'll be getting rid of that text up there in a second. Meanwhile, I'm going to just continue to look at any errors that I see along the way. And fix those. And looks like that text is set. We've got the birds chirping because according to the clock, it's morning time over here. And how are we doing? Whoops, that's not what I wanted. That's what I wanted. Welcome. Wow. That's a little bit better, I think. Thanks, Coding Gorilla. Appreciate it. It's the fanfare is loud. Let me fix that.
You seem a little better. How's mine?
You're probably always good, Rory. I'm going to turn the fanfares down on the Coding Gorilla right there for both of those.
I want to say our audio of you and me is now equivalent to each other, good enough levels between them. But yes, on the little bit I was listening to, the fanfares were quite loud by comparison.
Yeah. Now, I'm curious as to why we still don't see a fanfare for Codebase Alpha. That's what it is. It came in too soon. The code is still being played. What's over there? What's that? What's up behind you, Fred? What's that? Oh, the planet, Fred. It's a planet. It's a planet. That was what was behind you. Okay. Yeah, Codebase Alpha has teleported into the building.
Welcome, everybody. Codebase Alpha, Coding Gorilla, everybody's welcome here.
You're all welcome. Thanks so much. Use constant sed. Got this. So I'm just fixing these as I see them in the code and gradually getting the code up. So you notice we still got var here in a number of places. That's because we didn't know about let when we wrote this code, because we were just starting this.
We've been doing this for years now. It's just a disturbing fact, but true.
Yeah.
A very long time, certainly.
Yeah.
And we've been learning as we go.
Also, a lot of these lint issues are new with the new install of or with the upgrade to a higher level version of TypeScript, as I recall, as well. So I'm not going to do too much of these. I'm just like just I see them, but we are going to be working in TypeScript today. I'll tell you a little bit about what we're going to do. I like changing the vars to lets. I really like that a lot. It looks like that's going to be a constant. I got some more down here. This is in drone here. I'm going to just step away. I'm going to scroll up here, look like it's all good, and I'll be okay. I'll be able to step away from this. Almost. That's my last change. All right. So let me show you what we were working on. Let reminds me of basic.
Oh, so true. I remember that. That is a long time ago for me.
Yeah?
Yeah.
I worked in BASIC a long time ago. Yeah.
I started on BASIC age 7 on a Commodore 64.
By the way, Rory, so I teach my that's actually kind of cool. I just realized I should acknowledge what you just said. Commodore 64, what a fun computer to start working with.
Yeah.
Right? So I teach my son math. I started doing this again. You may have heard me talk about it before. I thought he was like close to a genius. Then we put him in a school, and they tried to do it, and everything kind of fell apart. Part of the problem was they put him up with a bunch of bigger kids, years older than him. And so he felt naturally, there was this other thing going on, this intimidation coupled with everybody was expecting him to know the answers all the time. Right. What's the whiz kid say? That's what they would say to me back in the, old days. And so, and so he kind of, felt diminished in terms of his spirit. But recently I started doing math with him again. And I said, oh, you know what I'm going to do? I'm just going to do this on a regular basis. I'm not going to do it like as a primary thing. I used to spend like an hour with him about every day. But I'm going to do it like, shorter period of time, like maybe, whatever, 10, 20 minutes, whatever it seems to last. But I'll do it on a daily basis with him. And the kinds of math I like to do with him are not really the kinds of math that they teach young kids. And what I was doing last time was we were determining the formula for calculating the area of a triangle, right? So we know, if you know from training, it is 1/2 base times height, right? Yep. But we were proving it. Right?
And proofs are interesting.
Yeah, proofs are my absolute favorite part of math, right? Because in some ways it feels like you're discovering something completely new and or retracing the footsteps of somebody who is discovering this for the first time.
Yeah.
And I've often thought about the equation for a triangle. And let me just I know I'm supposed to be coding right now, but we're going to go into PowerPoint.
Coding's math related.
Yeah, it's math related. You're right. So let's do this right here. So we start with proving it for here. And proving it for a triangle like this, which I think is called an obtuse triangle, is actually pretty easy to do. It's, here, let me show you. It's, let's do this. And let's get rid of that now. I've broken this into 2 pieces. And let's do this. And if we do this, any kind of triangle that you can break into 2 right triangles, like this one right here, send that to the back and let's change its fill color like this, then it's simply like, oh, I get it. It's 1/2 base height, right?
Yeah.
So if I've got it for that and I've got it for this, then we add these two together, we get the base, no big deal, right? The thing that gets weird is when we have something that goes out like this right here, right?
Yeah.
And now it's like, how do we solve that? And well, we solved this one by adding together two triangles. This one we actually get, the proof for this is in subtracting. And the cool thing about the proof is that you start with base here and height here, but then you create another variable for this piece. You want to call it A or something like that. And then if this is A right here, then you also have the total across, which is A plus B, B being the base here. Does that make sense? I don't know if that's clear or not. Yeah. What's cool about it is when you run through the proof, your temporary variable that you created to represent this distance completely goes away at the end.
It vanishes.
It vanishes. And it really, in that moment, I was like both excited, because I'd never done this before. I always kind of wondered about this. And I was both excited, and I really saw the power of variables there in a way that I'd never seen before. Right?
Yeah.
I can use a letter to represent any distance, and if that letter goes away, it's completely it's like a completely awesome, beautiful experience. So anyway, that's what we did, and I was thinking, oh, you know what? I'm gonna save some of these, and when he's a little older, I'm gonna take him through a bunch of proofs on things. You know, the goal being we're gonna prove. Let's prove. You know, let's go through all of these proofs in terms of things that we've taken for granted. The math that happens these days is often kind of procedural, it seems, where they say, here's the sequence of steps we want to teach your brain to do and memorize, and now go. And
there are certain facts that are useful to do like that. So basic multiplication is useful to just know some of those answers off the top of your
absolutely.
head.
Yes,
which
I agree.
Speeds up other things. But this is foundational, right? So you know, you can learn that this is the case, but will you really trust it unless you've seen the proof?
Yeah, I think you're right. And I think going through the proof also gives you retention, and it gives you an appreciation for the discovery process, right? Who came in and discovered it.
Yeah.
So yeah, it was, anyway, I'm still not down from that high. And I think I experienced it way more than anybody else. My son was not, I think it was like, okay, but I don't think he was really seeing the beauty of this. And I love too this idea of how do we get from point A to point B, right? How do we get from point A to point B when point B seems far away?
Yeah.
Right? What do we do?
Mapping out a path to a target and you're not entirely sure how to get there. The discovery of how to get from A to B by a series of digestible chunks, you might say.
Yeah. No, and I think practicing that is good. So speaking of getting from point A to B and how to get there, let's talk about what we're going to do today. So here's what I got. These are all my condition icons over here, right?
Okay.
I don't know if you saw these or not, but I think I brought these in on Friday.
Yeah.
They look.
We saw you get the plain versions, and there was adding some color, and there was a debate as to where could you get the rights to do this. But certainly it seemed like it was a good route to take.
I found the rights in bottom, so I want to share that too. So I feel pretty good about that. I'm like, oh, that's awesome. So it looks like I made copies of these, not realizing I did. But at any rate, here's what I want to do today. And you're going to be like, geez, Mark, really? Isn't it good enough already? I think probably, but then that's clear you haven't seen the show, because that's not what we do.
On this show, you can never go too far.
Yeah, well, I'll show you where I think just right enough is, and you'll be like, oh my God. That's what we're going to do today. So here's the deal. This is what I imagine to be real, and it's not real yet. I want to make it real. So it goes like this. Let's pretend all of these are off of here, and I've just become blinded. I want this to come up from the bottom, boom, and land like that, as if it were thrown. So I want it to behave as if it had gravity and land. When it lands, I want to hear a sound that makes you think that this is like a tile made out of ivory or something, some similar material.
So it's like the sort of Scrabble tiles hitting each other.
Yes, I want to have that chunk. The next one comes in. It's getting harder. It's going to come in, chunk right there. Okay? Land on top. The next one comes in, chunk. It's going to land on top. We go into battle and we don't have enough room. All of these are going to be scaled down, and then they're going to go chunk, chunk. Okay, they're going
Nice.
to fall down. Oh, I'm glad you said nice. I thought you were going to be like, that's my threshold,
No,
Mark.
that's good.
Okay, now when we've got a stack of these and one goes away, this is going to go, I think, it could just go poof and go away. That might do that. I think I might do that. But I was also thinking it kind of comes out and drops, is what I was thinking. And then these come
Okay.
down, chunk, and we hear the click, and chunk, and we hear the click. See what I'm saying? So they're going to feel like something we can almost tactily play with.
Physical, tangible objects that are interacting with the gaming surface.
Yes, that's what I want to do. Now, there's some, I haven't quite figured out how we're going to do this yet. I have some of the pieces here, but let's create a stack that's kind of tall. It has occurred to me, when they go away, they explode, distributing multicolored teddy bears all over the screen. Roy's like, Mark, say something to.
Well, see, Mark could go one of two ways here. He could either declare that's a little bit not quite the direction, or he could go, oh no, we can top that, and I don't know, maybe it's exploding dragon parts or something like this.
Okay, I was actually going to look for teddy bears here, see what we got in specifically in like stock video. What do we got? Stock video.
See, those are really cute. I imagine one of those walking along the screen, grabbing a tile and sort of taking it off screen like someone who's announcing round 2 at a boxing match, you know, just disappearing with it.
Yeah. So we could wait. What's this guy? Yeah, I don't know. Let's see what we got. We need them kind of like, you know, not standing, because, you know, we need something that we can kind of spin around a little bit here. Yeah. It's possible. Whoa, what's this? Oh no, it's too much. I need an edge, and it looks Christmassy.
Pieces of that, yeah.
Yeah. So I don't know. Okay, maybe not teddy bears then. Maybe not. It's I could maybe play with that. Like imagine a bunch of those all coming out and spinning, right? Maybe like that. I don't know. Kobe South is like, no, Mark, that was a joke. This is a possibility, I guess. I don't know too much has in Mark's vocabulary. Like, or bear with the balloon, releasing lots of balloons. I don't know. Let's look for balloons. Let's see what we got with balloons here. I don't know. Yeah, I don't know. I don't know.
We could have them dissolve as like sparkles or something using the particle engine, or
yeah, no, I'm kind of thinking different things here. I don't know yet. I don't know. Balloon, maybe. Well, let's see. Are these in alpha still? We're still looking at the alpha channel here. What I really want is like a balloon explosion, but I don't think I'm going to see much of that here. Yeah, just the cartoon stuff. Yeah, I don't. We could do this. We could do a confetti explosion.
Okay, yeah.
That wouldn't look too bad, I think, especially if we could get the whole thing. We've got alpha channels still, but I want it so it doesn't reach the edge of the screen. See, most confetti explosions that you get in stock video reach the edge, and I don't want to do that. It's hard to really, you really want them to just all come out and then kind of fall down. You want it coming at me and dropping is what you want. I could do something like this. I could use this to some degree. This is actually kind of cool. That could work, actually. Hold on a second. Let's go in and look at it a little larger. Yeah. We could do that.
That's quite nice.
It's really kind of fun. Okay, let's do it. There you go. Codebase Alpha, you have now, to some degree, changed this. Changed the course of history forever. All right, so I'm going to put this. I've got a folder over here called E for assets. I know assets has.
If this goes wrong, we're blaming Codebase Alpha, right?
Right, and so this is going to be condition. I've got conditions glow here. I might rename. No, I won't. I'm going to come in here and I'll say conditions explosion, like this. And I think I'm actually going to build it out of a couple pieces. We'll have the confetti thing and maybe something else as well, right? Something that just comes out as well at you. But I'll put that down. I'll download it for now. It's actually already downloaded. Let's see. Instead of confetti explosion, what if I use burst instead? And I'm really, what's this? Not looking good so far. I want it totally, I want it totally sealed. No edges. Getting rid of edges are so hard to do because it never looks good when I do it. That's what I'm looking at, but without the edges there. I could actually fake this. I can fake this with the other and make it work. We'll do that. That's not too hard. All right, so there we go. We've got our exit animation software, at least the assets for that built. All right, back over here. So let's say I'm here in this scenario.
Yeah.
Okay. And I want, so by the way, to make all this work, it feels like it's tricky to me. It does not, there's no intuitive solution in terms of how I'm going to represent things structurally in the data to make this work. Cody Gorilla says, or the bear, wait, so I think someday I want, someday want to have a cool idea like Codebase Alpha. Someday, I think you were saying that. Is that what you're meaning? Yeah. I think that's what it is. All right, so say we want to get rid of poison. Yeah, someday, yeah. So if I want to get rid of poison, like this, these two aren't moving. So I need to know which in the stack are not moving, and I got to find the ones, which ones are. Then I got to take this one down first, and then start this one a little bit later, and this one a little bit later. It's going to do cartoon-like dropping, right? Where, you know, the anvil drops first, and then the coyote drops right afterwards. You know, that sort of thing, where, you know, the shoes drop, and then the person drops.
Yep.
That kind of thing.
This is slightly different, though. We've done something similar in the NPCs where they slide up when you remove one. However, these are going to hit each other. They're going to land on each other.
Right. Yeah. So it's
so if the first one hits, if there's any level of bounce that comes back up, that bounces back up into an oncoming item unless we slow them down.
I'm not going to do. I'm going to fake it. I'm not going to bounce.
Okay.
I'm not going to throw that much physics at it because I don't want to. I want to be here in a day or two, not a week or maybe two. Is what I want to do.
Enough.
Okay. So I'm going to fake that part of it, but I think, you know, part of what I'm doing a lot is I'm thinking, okay, what is the mind of the observer doing? What is it going to be what is going to be needed to convince them it's real versus going all out and making everything real, right?
Sure.
Sometimes I might just, all I need is maybe like an animated explosion at some point, and people are like, okay, I buy it. It feels totally real, right?
Sure.
One of my examples that I really like that shows this are these guys. It's one animation, right? That just flaps the wings, right? But because we're changing things like the frame rate, we're changing a lot of other things on these, the size and the scale, all of that. It feels like a bunch of different things, right? Even the flying up, that's just using our ease animation. It's not even there's no physics there. I say it's one animation, it's actually two. The second animation is the fire breath that's coming out as well. But those two combinations of pieces there, coupled with a different die in there, coupled with the hand animation being separated over the top so we can make it look like the hands are on the die, all of that has worked really, really well to make that look and feel like something you want to play with almost, right? And you want to say, okay, it's Fred's roll, let's bring it up, that sort of thing, right? Or bring it down when you don't want it to be the roll. So I kind of want the same thing happening with conditions. Now the thing is, from a practical standpoint, conditions are rarely occurring in multiples. Okay, they're kind of rare state related things. However, I want it to work with multiples, so I kind of have to build it and test to work in the edge case situation, even though that may not actually be happening.
Well, that's the usual problem, isn't it? So something may be rare, but that doesn't mean it's impossible. Because it's possible, it might at one point happen. And if it doesn't work when you need it to, suddenly the illusion is dispelled somewhat.
Yeah, no, you're right. And that's what I'm trying to prevent that from happening. So the other thing that we should know about this is that our sprites are essentially in an array. Our sprites are kept in an array. It's the flyweight design pattern. That is something that we've had going on for a while, and that array has many sprites that may not all be in the same column. Okay, so that's challenge number one, is that the way we're storing the sprites, right, and knowing that those pieces out there, that's where they are. Now we can create a separate data object. Here, let me move this off to the side here so you can see it a little bit more. I know we just saw that I was blocking it. We can create a separate data object, but I don't think I'm going to do that. Instead, what I'm going to do is when a change occurs, I'm going to search through the array, and I'm going to then collect into a group above and below is what I'm going to do. So I'm going to go like, you guys are coming over here, and you three, I'm going to find you and put you up here. That's kind of what I think I'm going to do. Whoops. And when I say put them in a group, I'm not exactly sure everything that may mean. It could be that I instead just store data in with the sprite that tells it what group you belong to. And I haven't quite decided, am I going to create separate classes to maintain top and bottom? Because I only need them for a moment. Or am I going to go in and talk about state? And I'm actually leaning towards state here. So right now, by the way, I've got a piece called data. Let's go look at our conditions here. Let's look at some code for a second. We'll come back in a second here. Conditions. Update player conditions. And add condition. Let's go look at that. So in add condition, I set the data equal to the player ID. Okay? And then, you know what I did? I'm not proud of it, Rory. I created a new property called tag because I needed two pieces of information. I needed the player ID and the frame index. So let's start talking about so I've got this data, and then I created something called tag to hold the player index. I did it because it was fast. It was the fewest amount of lines of code to be able to add that tag, and I use it only in this file right down here, right? And I'm just going in remove by data plus tag. The reason why is this, is the sprites are kept in an array, and the sprites are an array of sprite proxies. Instances, one for each animation. But also, hold on, let's get this, start doing this. I think this is, but also there is a base animation with all the images for the animation. Now, why is this important? Because the frame index property of the sprite proxy tells which condition to show and which condition you have.
Yeah.
Okay. So so that frame index is in there. So when we are searching by the frame index, what I'm doing is I'm putting it in the tag value instead of actually using the frame index for the sprite itself, because I ran into other blocks that were stopping me from doing that. But this is what I did. I created this data and tag property, and that was a hack. So let's just do that. I believe the data property by itself is okay, but adding the tag property was a hack. So the data, and you could similarly argue that the data property is a hack, and that there are other ways to solve it. But I don't think you have a compelling argument there. I think you have a medium compelling argument. You're basically saying, look, use something else like inheritance instead of composition or something along those lines, which we could do. Like in some cases it makes sense, but to create a descendant of the sprite proxy just to hold this additional data doesn't really make sense to me either. We've got a lot of choices. None of them, and I think the other thing I'm doing when I'm weighing choices in design is I'm thinking about how much code, how certain do I know, how safe is the code I'm going to write because it's going to be. Hold on a second. You should define the data property as an object hash, and then you can just duct tape properties on it as needed. Show me what an object hash is. I'm going to go search for that now. We'll see if we can find that. Are you showing me when characters have inspiration at the moment? No, I'm not. I do have an inspiration icon for it, but I was like, yeah, I don't like it. It's the inspiration super rare as well, but I do have it. And I could add it. It's not hard to add. So if I wanted to add it, it'd be like 3 or 4 lines of code and I'd have access to it. So, but I'm not showing that right now. Data like that. how does that impact existing code that uses data? Because like a lot of code, let me go just look at this. Like here, for example, we're passing the player ID as data. Is that gonna, can we still use that code if I define it as an object hash? Or do I need to change this to data.playerID or something like that? That's my question. I'll tell you where I was going with this while you're thinking about that and giving me suggestions on that. What I'm thinking about doing is I'm just thinking about assigning an object to data. You have to do something like data.playerID. Yeah, everywhere. So I've got a lot of code I don't want to change. So instead of doing that right now, Coding Gorilla, what I'm going to do is I'm just going to create my own object and assign it to data is what I'm going to do. So I'm going to do that, and my object's going to maintain all the things I need. So it's going to have the player ID, it's going to have the frame index, which I apparently need both of those, and then it's going to have stuff to maintain this state here, right? For example, I'm just guessing here that we need this, is above.
Geniscu 7, where are you? We need your help.
We do need your help, Geniscu 7.
Oh, yeah, all right. Here, I am.
Notice here, also to save the day. Where's my Stream Deck? I just noticed my Stream Deck stuff isn't up and running. Looks like I lost an icon for it. Maybe they updated? Oh wait, Stream Labels, I mean my Stream Labels app. Where are you? Now it's starting up. Yeah, it looks like their icon changed. And I lost it off of my taskbar. I'm just going to pin it to the taskbar now, so I've got it. Cool. All right. Now I'm looking for OBS. There's OBS right there. All right. So I might have some additional data here, but we'll figure this out as we're writing the code. Where are you? What are we going to need? Is moving meaning, is this going away or coming back? I think we also need a scale. I think we need a scale in here too.
So you're saying that above maybe 3-4 items, you're going to reduce the size of things so that more items can fit in the stack.
Yeah, there'll be two constraints. How much does it fit this way stacked? I'm okay with it stacked all the way up to the bottom of the players. These guys right here, right? So I'm okay if it comes all the way up to that.
Sure.
I don't mind that. I think it's kind of funny, and I'm also I also want to though. The other secondary constraint is between these two characters. Like when we do a game, we've got full names here often, or we've got other stats like if we're in battle. And so the width of these move. So right now, if we look at conditions, like if I go in and say, okay, let's go to my conditions, and we say, let's make me blinded. There you can see, that's what it looks like now. So this is what we got to on Friday. It appears in the right place. It's not scaled, I think. It's not scaled intelligently. If there's any scaling in there, it's dumb scaling. But we can just choose the different pieces, but we can only show one because it's not and it doesn't animate its way in anything like that. So it's whatever the last one pressed is, that's the one that shows up. But if we go into battle, here, let me go into battle with you. I think when we go into battle, they'll scale. Let's go into battle. Notice the size of the nameplates goes up.
Yep.
And now we're going to come in and do that. Notice it does scale if it's in battle. So if it's in battle, it knows it should be a little smaller so it can fit. So I want that to be more intelligent, which means we've got scaling transitions from a large scale to a small scale. There's lots of complexity in here. That's new, by the way. I don't know if I think you saw me building the artwork for that on one of these.
I think we did.
Yeah. Isn't that cool? Did you like that as much as I did? I love that.
Oh, very nice.
Yeah. So yeah, I'm pretty happy with these, but I want to be happier with them. So I think the first thing we're going to do, let's take the music. Let's take we'll stop the music there, and we'll start our own Code Rush music over here on our side of things. So let's start at least going here. Let's do this as our first two tasks. Let's get rid of tag. Let's put the data in player ID and frame index, and let's get it at least to hop in like that. Okay? How's that sound? I think e317 says that's a good idea. All right, so let's do that. Let's go write some code. Figure that out. That's going to be step one. It was over in conditions, which is, I think, over here. All right, let's go find tag. Tag is there. Let's go to tab to next reference on this guy. Nope. I'm going to just put this here as a reminder that I need to do something with that. Same thing here. And no tag there. Any other tags down here? So what I want to do here is I want to say, let's start creating our object, whatever that class is going to be. I'll throw it right here. We're going to call this our condition state. And that's going to have inside of it player ID. That's going to have a frame index. At least those two for now.
Missing a comma between those. There we go.
Okay, and let's go back to where we were. And so we're going to say, hey, I think it's going to look like this. Constant condition state equals sprite dot data as condition state. Then I'm going to say, hey, if condition state and condition state dot player ID equals data, and I'm going to rename data in a second. And condition state dot frame index is equal to tag. I'm going to rename that too. I'm going to rename it right now. Then I'm going to say fade out now, like that. And let's rename data to player ID. And let's rename the function all right, we'll do that. And we're only using it in those two places anyway, so it's okay to send that in. So now we've got this, it's better right here. Now up here in data, we want to say, okay, that means that's going to be equal to a new condition state, and we're going to pass in player ID and frame index right there. That's data. And I think I'm not going to get in too much trouble by just simply referencing that here. I think I can just reuse the object there in both of those places.
Yeah.
I'm trying to think of like what's going to interfere with garbage collection. I don't think so, because this is the only thing that has a reference. It only has a reference to it. So I think that should be good. Is that true or no? Wait. If I'm trying to destroy this and this has got a reference, no, I can still destroy it. That should all be good.
Yeah.
Everything should all be good. It's if this has a reference back to it, that I would have a problem. Okay. All right. So that should result in no changes to behavior. Let's just test that and make sure that works. That's in the front overlay, so I'm going to turn it off here on the live stream. Refresh it here, and then I'm going to go to my Stream Deck buttons, and I'm going to hit a condition incapacitated. Looks like it's working. Turn it off, invisible, turn it off, good. Okay, so that seems to have worked. We got rid of tag, that's step one. Step two is, I think, having this thing jump up onto screen. We've got both a sprite and a glow that we need to work together on this. Yep. Also, notice the similarity in the properties right here. I'm going to do this. I'm going to say this dot prepare condition for entrance, and I'm going to pass in that sprite. That's what I'm going to do. And then I'm going to set those in there. And then we're going to call the same thing from down below.
Okay.
Did I totally fail to extract that as a method, or I did and it just didn't give me player ID? Trying to figure out what just happened. I thought I extracted that. Oh, no, I didn't. I didn't extract it. Let's extract it. I just typed it in. All right, let's do this. Extract method. Let's rename it. Better. Okay. Okay. So now, it's just a real quick test of that. Should be no change in behavior. Refresh. Bring up a condition. There it is. Looks like it's working. Okay, good. So that's good. Now we want to have it jump in.
Yep.
I'm just trying to figure out, how do we know when it stops? We do something similar in one of the games where we throw in those kind of silver balls that once they land, once they hit their apex, they open up. And I think we do that by time is what we do. We calculate the time it takes to get up there, and then we do the opening. And then so we have a timeout that when the time passes, then we say, okay, now get really in your correct position. So if it's off by a pixel or two, it just moves it in the right space so it's pixel perfect and opens up. We can do the same kind of thing here, I think, as well. We kind of need to calculate, you know, where it is and where we're going to. Where we're going to is actually, we know that already. It's already here in terms of its X and Y positioning. Okay. So let's see if we can figure this out. Let's see. I'm like, you know, I've got a couple ideas in terms of how we can do this. I'm thinking at first, I think we need to do this. We need to say sprite dot horizontal thrust override. Sorry, no, vertical thrust override. We're going to give it a vertical thrust override. So here's the deal. We want these sprites, we want to be able to move them using easing. Yeah. So that means we don't want the gravity to work on them. So we set, when creating these, let me jump up here so you can see this. Hey, baby, how you doing?
I have a question for you.
Go ahead.
What's the name of the Bluetooth speaker in the living room?
It's like blast. It's got the word blast in it or something like that. Like big blaster or something like that.
That sounds really... Oh, is it Beat Blast?
Yeah. BT Blast. I bet that's it. All right. That was a question on the Bluetooth name. You got a lot of Bluetooth stuff in there. Wait, what are you doing? No. Jenny27 says, like those walls. Yeah, I think he's talking about the walls in the game, in the drone game. We were talking about that. All right, so I want to give a vertical thrust override. Let's say make it equal to 9.8. Let's just make only that change, okay?
Okay.
And see what happens. Just to see what happens with the physics of this thing. Okay, let's refresh. Let's add a condition. Okay, it dropped. Do you see it? I'll do it again. Here we'll do another one. See it? It's just dropping right down.
Yep.
Yeah.
Okay, good.
All right. So let's do that. Let's also give it a vertical thrust, no, vertical velocity, velocity Y. Let's set that equal to 6. I don't know. I think positive is up. I think I changed the physics. I made the physics so positive is up. Let's see if it is or not. We will refresh that and do it. Nope. I'm going to make it negative. Let's just double check it. I'll hit another button. Yeah. It looks like it's immediately going down. We want to change that to a negative 6. All right. So we'll do negative 6. Refresh. And there you go.
Not bad.
Yeah, I actually kind of like that. Nice. I actually like that as a kind of thing coming in, right? It's kind of, it kind of says, hey, look at me.
So instead of left to right bounce, it's kind of bouncing from back to front almost.
Yeah, I'm going to change the fade-in time to 100 milliseconds instead. And let's do that. Refresh it and hit the button. Yeah. I love it.
That's cool. Yeah.
It feels natural, right? That's what I'm looking for. Okay.
It's a nice arcing curve, very natural.
Okay, next. We need to do some math.
Okay.
We need to do some math. Let's at least draw a picture of what the math is that we need to do. We need this thing. We need this to go. Well, I need to do a bunch of these in a row. Is there a shortcut for this? If I double click it, will it give me a bunch? No. I really want to double click to give me a bunch of these. Nope, I got to do it each time. All right. Anyway, so I'm going like this. And then we're going to come down and land, right? So we need to do something like this. And so let's assume that my landing point is here, but my starting point is down here, right?
Yeah.
So what I need to do is I need to calculate the time for it to get from here to the apex and then drop from the apex down to the new piece. We'll assume that the apex is this distance from the new location, the landing spot to the apex will always be the same. Okay. Oops, what the heck is going on? That's not what I wanted. Home. I wanted to come down here so that this distance from here to here will be a constant, whatever that is. See what I'm talking about there? That the apex is there so that we can calculate the drop time as well.
So we're going to go to a different apex each time so that the drop will be identical each time.
Yeah. Now, here's the thing, kids. The throw to the apex is the same. The time it takes to throw to an apex is the same as it takes to drop from the apex down to the ground. Okay, and you're landing at the ground or whatever, the same height at the same velocity that you left from, because we have no wind resistance in our physical model. So this is whatever this distance is here. That is. Hold on a second. I'm just thinking. I want to make this. I want to have the start off. The starting velocity always be the same. So we're going to always have. I love this -6. The -6 is working for me. Hitting the button now and not seeing anything. Why am I not seeing anything now on this? There's one deafened. Oh, because the other ones were. I hadn't turned them off. They were still alive and just falling, but falling off screen. Okay.
Gotcha.
So that intro speed, I'm happy with that, except for, oh shoot, it's not going to make it all the way up to tall.
I was going to say, if we've got a variable apex, then if you want it to take the same amount of time, we've got to have variable speed.
Yeah.
Or initial velocity.
Yeah,
anyway.
yeah. And I think you're right. I do want to constrain by time. I was totally thinking, no, I really like that velocity, but you're right. I'm going to constrain by time. So let's say we want to get up from here let's make a constant for that time, whatever it is. So let's say time to apex, and we're going to set that equal to 1500 milliseconds.
Okay.
Let's try that. Time to apex is 1500 milliseconds. Let's say we need another constant in here, which is going to be represent this secondary distance right here.
Fall distance.
Yeah, fall distance. Yeah, exactly. I like that. Fall distance and I'll go ahead and say px here. You know what? I'll change that 1500 in a second once I think about it. And I'm gonna get rid of this milliseconds here, but I'm gonna instead put it here. I'm a big fan of putting units on constants. So my fall distance looks to be, how big are these? These things are about 80 pixels high when they're scaled at this size. So my fall distance is about 80 plus 80. It's the size. I think it's going to be 80 times 2.5. 1, 2.5. 80 times 2.5 times scale. That's what I think that is. And actually, wait, change that 80 to 102 because that's what I think the real size of these are. I'm thinking maybe it would be smart to double check that. Let's open up a Explorer window. Go out to Assets. conditions. What's our dimension? 102 by 102. Okay. So we're going to take 102 times 2.5 times the scale. That's my fall distance.
Yep.
Okay. So now my time to apex is there. My final resting position. Let's do this. I'm going to store my final resting position in my condition state. Okay. So we'll say PB, TN, final X. Oops, need space. Final X. And I'm going to select from here to here and shift enter to duplicate that. And call this one final Y. Okay. All right. Back over here, my X and Y. That's going to be my sprite.x.y, I think. Sprite.x. Sprite.y. Then I'm going to say, next we need to calculate the distance to drop. So I'm going to go into my physics engine, and I've got just a couple functions inside of here. Get drop time. There it is right there.
That seems pretty apt.
Drop time. The height in meters. I'm going to go to my physics engine and say, what do I have? Pixels to meters? As if we knew what we were doing, Rory.
Oh, yeah.
There's my fall distance px right there. Pixels to meters. Oh, wait, that's not it. Hold on. Wait, no, yeah, this is my drop time.
Yeah, we're going from pixels, which we have, to meters, which the get drop time requires.
Yeah, I'm solving this end time right now, from here to here. I'm solving that end time. I need to solve this time as well.
True.
Okay. And we're going to say, I think we need a constant, a type number, call it apex y. Apex y is going to be equal to sprite.y minus fall distance px. Okay? So we also need to get the drop time from that as well. We'll find that in a second. Whatever that distance is to bottom. So we maybe need another constant in here too. Fall distance is equal to 1080 minus apex y. Is this math correct? My apex y, sprite.y, the y position of the sprite minus the fall distance in pixels. That looks right. And so my total fall distance is here. Or maybe we'll call this distance to apex. Distance to apex, I think is what we'll call that. Distance from
the top, because we figured out that that's where it's based.
I'm going to say distance from below ground to apex. And so I'm going to now create another constant, my below ground place.
This, everyone, is what abstraction is all about.
And I'm going to call this 1080. And I'm even going to maybe magically come in here as well. Do one more. Screen height. I know. It may be a little overkill for some of you out there.
No, I think this is good. I think it's good because you can easily rationalize what a single piece of this equation is about by having aptly named constants and other variables. And so you can solve a piece of it, and then you can use that piece and build on it for the more complicated assemblage.
Yeah, so I'm going to come in here and just start using these pieces here. So there's my condition height there. My below ground is actually going to be my screen height plus my condition height. And I think we can say time scale here. So that's where I'm going to start. I think my fade in time I'm going to drop down to 50 because I just essentially want it in as it comes in. Self-documenting code. Yeah, Coding Gorilla. Yeah. No, I agree. Yeah. I said some of you. I feel like Coding Gorilla would be on board with this. Okay, so let's see. Below ground y is equal to screen height plus condition times scale. Good. Distance from below ground to apex is going to be equal to this minus apex y. Good. That's my total distance that I need to move to the apex. So here we're in the middle of this. So get my drop time. Acceleration is going to be equal to my sprite.vertical thrust override. Is what I believe is there. That's my drop time. That's my drop time to the, hold on a second, let's declare that. Drop time to land, I guess is what I'll call it. I don't know. I don't know a great name for this. That's my drop time to land is that. And then I have another one, which is my throw time to apex. Like that. Now this is going to be, oh wait, I've already got time, wait, time to apex milliseconds. I do want to use this, never mind. So wait, I don't want that. I don't want that. I want my throw velocity,
Yes.
Throw velocity
because
y.
you want your time to be a constant, and therefore you have to adjust the speed in order to get to a different physical location within that same time.
So I'm going to call get final velocity, and my
I'm going to
time.
scroll down just a little bit, Mark. Your head is somewhat in the way. That's it.
Perfect. Thanks so much, Rory, for that. I really appreciate that. So time to apex ms is there. What's the next one? Initial velocity is going to be 0 because that's going from the apex down, right? The acceleration is there. That's it. So my throw
velocity is from the ground going up.
Yes, it is.
Not from the apex going down.
Right. It is. So what I do is I'm calling get final velocity as if I dropped it from the apex. When it hits the ground, whatever that velocity is, you reverse that velocity and it's going to go up.
I see. Clever.
Okay. Yeah. The only thing I'm not sure about is if it's a minus or not, and I think it's a minus, is what I think. I think I need to get a minus on there.
I think it is a minus because it's going up, and we think the origin is at 0, 0 in the upper left.
Okay. So now we need also know now the total arc travel time, maybe the total travel time, that's going to be equal to the time to apex. So we've got, no matter what, the same piece right there, time to apex at ms plus the drop time to land.
Yes.
Okay, that's my total travel time right there. Hold on, let me just fix some of these issues here. I don't need to do that. I don't need to do that. This is just not used yet. Not used yet. Okay, good. Now, I need to change the sprite's position here. So I'm going to say sprite. I'm only going to worry about for this next run, only the Y. But once we get the Y working, I'm going to move it off to the side so it's got an arc.
Okay.
Okay. So say sprite.y is equal to below ground Y. Okay. Then I'm going to say sprite dot velocity y is equal to throw velocity y.
Yep.
Okay. Then I'm going to say, what else do I need to do? I've got the vertical thrust override. That may be all I need to do. What's this distance from below ground to apex? Oops, did I not use this? This should have been used. Oh.
That's to be used somehow in the throw velocity, isn't it? Because we need the distance that you've got to cover in order to get to that apex. That's interesting. We have no distance component in there.
Yeah. Yeah. I think I need to pass in. I need to do this, I think. I need to pass in get drop time here. This in here. Like this. Wait. My drop time is my throw time. Right? I want it to be there no matter what. I'm going to get the final velocity of that. Is this going to, for some reason I'm thinking this is not going to work by saying I always want to be able to throw up to that at that time, but that should work.
We need our velocity, our distance, and our time. The time is a fixed fact, and therefore the velocity should increase relative to the different distance.
No, I think this is expressed distance. Yeah, we don't really care about the distance. We don't. We really don't. How is it going to get far enough up, though, is my question. We need to make sure that the time to apex is enough time. Do we need to make sure final velocity?
I think we do care about distance. If your time to apex is a fixed constant, then the other two are variable, and you can only calculate one variable by feeding in both your constant and the other variable.
Yes, I agree with all that. What am I missing though? I feel like I'm still not seeing this.
So your line 1193, which is calculating a final velocity, has a final velocity as its output, has a time to apex on it as an input, but no distance.
Yes.
It has no distance from below ground to apex. That needs to factor in somehow.
Well, we need to make sure that that distance is enough. Here's the problem. Now I see the problem. The problem is we've got a fixed time to apex. What if we're wrong on that? What if we're we don't actually? I don't even want to. That's not what I want to do.
That's a choice, though.
Yeah,
you can either decide it's fixed or decide it's not.
Sorry, to be clear, when I said what if we're wrong, what if we don't have enough time to get it up to the top? Or what if it's so big that we have to throw it way off screen and wait for it to drop down, right? What we really want is we want to go back to this piece right here, figure out this distance above here, calculate the distance to the ground, find that drop time to there. That's what we want to do. So we do want to use this right here. So let's do that. Forget the time to apex.
Okay.
At least not here. We're going to make that a constant, and we're going to calculate it. So we're going to say time to apex is equal to, and we're going to use that here with physics dot get drop time pixels to meters of that, comma, and then you just get the rest of the stuff below here, like that. So now we've got time to apex, drop time to land, throw velocity y. Now we have time to apex. We're using it there. Now I'm much happier about that. Okay?
Time to apex is now the same value as drop time to land, though. Is that correct?
I don't think so. It's not.
You've got the same calculation going on, haven't you?
We have a different variable
different
here.
Distance, sorry.
Different distance. Okay? That's
Fair
what we
enough.
got. So I'm feeling good about that. Total travel time. So we want to do something. I think I'm not going to do anything yet, but let's just do that and see what happens. See if we see it. If we don't see it, we probably got our throw velocity y is wrong.
Okay.
Okay? That's what my guess is. But let's just see what happens. Music's perfect for whether this works or not. What you're doing looks super hard, Zetawap says. I don't know.
Welcome, Zetawap.
Well, here's the cool thing about it. Yeah, welcome, Zetawap. The cool thing about it is if we make this work, we're going to look like geniuses.
If this works, it was all completely on purpose.
It's not bad. What is wrong with... Why is the background separating now?
Glow is
It's got a different
traveling
velocity?
differently.
It's like it's got a different velocity. But it's not bad.
They're different? No, hang on. They're different sizes, that's true, because one goes around the other. Does that matter here?
It could be their... it could be their origins are different, but that shouldn't... That should just be off by the whole thing. That doesn't quite make sense to me.
If the origins are different, that would actually help, because they need to be off relative to each other to sort of sync up.
Oh wait, no, I figured it out. It does have to do with the origins. We're going from the Y position, but the Ys are different on these two because of their origins. The origin's like an anchor. That separating glow is amazing, says Coding Gorilla. Yeah, you like that, huh? Woohoo!
Yeah, it was totally on purpose, but now we're going to change it.
Because what's happening is we're getting a different apex piece that's happening here. So I need to come in. I need to get the sprites and pass it in here. So let's add that as well. So we're going to throw in our conditions as here, and our condition glow, pass that in here, because that holds the anchor position of each of the sprites. So if we're going to come down here, type in VSPS like that. That's going to be our sprites like this. Okay. And whoops, I wanted to call it sprites with an S on it. And this is going to now, we should be able to, where are we using our X and our Y here? It's just in those two places. So I think what we're looking for is this, sprites dot origin Y plus. It's either plus or minus. I always get these mixed up. Let me see if I can calculate it in my head here a second. Hold on. Origin Y is there. So So I say here we subtract there. We need to add it. I think we need to add it. That's why my tiny little brain is telling me now. So let's try adding that and see if that's enough. This right here, I think we also have to come in, and if we don't do anything here, and I think it's a minus. That's what I think. Let's see if that works. We could be completely wrong. But it looks like we were completely right.
Looks good.
Do you like it when that happens, Rory?
Oh, very much.
Are you like, Miller, you're a genius?
Miller is a genius.
Look at
His
that.
maths is very quick and very far ahead of my own at this point.
Zetawop, see what
Look
I'm
at the
talking
style.
about? It looks super hard. Do we make it work? Like, whoa, whoa, whoa. Yeah,
Oh, yeah.
that's high school physics right there, kids. We just did some high school physics. All right, so that's good. Now we can start tweaking things. We say, well, is that going up too high? I think it's going up too high. So what is that? That we want to, the fall distance is here. Fall distance is really 2.5 times its height? I don't think that's true. That's way higher than that. That's like 5 times the height. Why is our fall distance wrong? Get drop time pixels to meters. Wow. Now we don't look like geniuses anymore. This is TypeScript, which is a wrapper. Kind of like a wrapper
It's a
around.
wrapper. So this compiles to JavaScript and thus runs in the browser and in fact in our OBS instance so that we can project this across during the stream. But it's a typed version of JavaScript. So everything that's legit JavaScript works as TypeScript. But we get to define types like string, number, and things like that. Just to make things a little bit easier, we can define our own classes too. And it's proven very useful for helping us find and structure our code, find bugs and structure the code well.
The voice you're hearing is of Roy, my partner on this, my
Random guy Mark picked up on the side of the street just before the show.
Yeah, co-programmer, that sort of thing. Fred's over there off the side there. He doesn't talk much, but he'll wave to you. So this is like this is like a little unsettling to me. Like it kind of works like we want, but based on our calculations, it should have only gone 2.5 times its own height times the scale, which is I think 80%. So its fall distance. Whoops.
Pop it up on screen again. Let's just have a look at that one more time.
Sure. Give me a second.
I've got measuring devices up against my screen now.
Yeah, it's like 5 times it looks like to me.
Yeah. Twice is about, I don't know, level with your glasses perhaps. A half time. It's almost correct if the 2.5 times measures at the bottom of where it goes to rather than the top. So if you picture the tile at its apex, at its highest point, and then 2.5 tiles could fit under it rather than within its top value. Is that? I'm trying to think. Maybe that's even too big then. Right, that's there and that's there.
Here's the problem. I'm so tempted to come in and tweak it. Right? Come in here and say magic number.
Mm-hmm.
Like this. Magic height factor. And then mark it as like a bug to fix later. So I'll say 0.5, and then I'll say hack, figure out, and remove. I actually like this.
What happens if you change the 2.5 temporarily to just 1? Where would we expect it to physically reach on screen?
Okay, let's try it.
Would it just appear a full tile, or would it be a full tile's gap underneath the tile?
I want to know what Mr. Swoopy thinks about that. This train's supposed to arrive any minute. Where is he? He's away. There he is. Mr. Swoopy's here.
Welcome, Mr. Smoothie.
Just in time to help us figure this out. All right, here you go, Rory. Yeah, it's still high.
Yeah, that's definitely higher than a full tile, isn't it?
Yep.
But it's much clearer that that is the case.
Yep. And are we coming from below the screen? Hard to tell. It looks like we're actually not.
It's almost as if the scale is not scaling down for the purposes of the gap calculation.
I wouldn't. I wouldn't.
Because those tiles are bigger before we shrink them, aren't they?
Yeah, this is actually 80% of its actual size right now. So
Oh,
this
okay.
scale coming in should be about 0.8, if I'm recalling correctly. I guess it's handed here to add condition. Yeah, here it is. So it's either 0.8 or 0.65. So that's what we're doing there. Yeah, so I'm going to do this. I have another option here, and that's to do this and to do this. I think this is not going to go well. Let's try it. Let's just try it, though, okay? Do you agree, Rory? Are you like, what are you doing, Mark?
I'm like, what is he playing at?
Yeah, that's definitely not...
That was not right.
Not working. Don't even think about that. It's awesome, though. That's sweet. Don't even... Yeah, I didn't pretend that never happened. Okay, so we're going to change this...
All the evidence again.
2.5. There's no evidence that happened. And I'm going to multiply it by this guy. And it's got to be less than this. So I'm going to make this like a 0.2 maybe even. And that'll be... We'll try that. Let's do that until we get this about where we want it to. Zetawop's going to sleep. Hope the programming works out. Thanks so much, Zetawop. Good, nice to have you here. Come by anytime. Ask questions anytime. 3 a.m. in Australia.
Yeah, you totally deserve some sleep.
Get some sleep, my friend. Okay, so now let's try it. Better.
Does that really feel like 0.2 of what it was?
Oh yeah, nice observation.
5 times more than that before?
Nope, you're right.
Seems unlikely.
No, you're really right. The only way that's 0.2 if this was somehow this is very far down off the bottom somehow, I guess, and somehow we're changing that launch point, but we're not. All right, maybe it's worth pushing down through this and looking at this one more time. Fall distance here, the apex is equal to sprites, so this gets the regular Y position minus the fall distance in pixels. Well, you know, we could also do this. This is going to take a little longer, but we can start throwing this stuff out. We can figure out what the calculations are for that. The fall distance there, the apex, Y position, the below ground Y. Just from below ground to apex, might as well do it now, I guess. And drop time to land. I really only care about distances because those I can at least measure, get a sense what they are.
Because this is all relative to a base graphic size of 102, which is down to 80% of that, so fractionally over 80 pixels.
Right.
And
we're going to multiply that by
based on that.
2.5, so it's 80 times 2.5. So we're looking at about
2.5 tiles high.
Yeah, that's what we're looking at. That's what I'm thinking. Let's throw scale out here too, just to make sure.
Does that mean that you expect it to drop effectively half a tile from its apex? Ultimately, that is to say, onto, let's say, 2 tiles that are there. So if you were firing this, actually, I suppose that's... Never mind. Let's not complicate matters anymore.
No, you actually got me thinking about something here. So... let's think about this a second. My fall distance in pixels, this is in the second half. I just want to get the visualization here, right? It's like, this is my fall distance in pixels, like from here to here. Let's do this. This is actually a great time for a picture.
In the case of your first instance here, where this is just the first tile coming on screen, is your fall distance not almost exactly the same as the apex minus, let's say, the height of a tile? Since it's coming from off screen
Yeah.
and is expecting to come back down to just barely on screen, there should be almost, you should be able to prove those two facts.
Yep, I agree. Hold on. Let's do this. I'm going to get all of these over here.
Because I've been mistakenly picturing the tile falling onto an existing stack of tiles, but in our first instance, that isn't the case. It's just falling onto the ground.
Right, and it should start from like below ground, so about right here, like there. Maybe I'll get rid of that. I'm going to come over here. Let's start labeling these pieces where they are. Okay, like that. Let's go to... This will help us visualize it a little bit better. I think we may have a map there, and I actually think we're about to review it and find it. So I've got fall distance and px. That's this piece right here. Let me do this too. Since these are not measured pieces, I want to just make these lower contrast, so we don't. They don't really take our focus, pull our focus away from the important pieces. So I've got fall distance px there. Then I have apex. Is it apex y? Distance from below ground to apex. I have that right here. That's this guy. Maybe I'll mark that right there, like that. So there's that guy. And I'll have below ground Y. Which is going to be this piece right over here. Oops. And let's duplicate this.
Below ground Y has to be the height of your screen, so about 1080. Is that right?
No,
That's
below
fixed fact.
No, below ground Y is the distance below the ground. The 1080 is at the bottom. This is 1080 right here. So if I draw a line from here to here, this is my Y equals 1080 line right here.
Yeah, but is that not exactly where the origin, the upper left of your tile, is positioned?
It's actually anchored in the bottom right of it, but
I see.
But it should not matter because we're trying to get rid of the anchor. We're trying to get rid of, so we're just thinking of a point when we're doing the math here. But because both the glow and the tile have different anchor positions, we need to kind of like we need to normalize both those so they're actually both pointing to the same spot. Yeah. This is my Y equals 1080 line right here.
AKA the ground.
Yeah, AKA the ground. Let me take this and bring this over here like that. Let's change its color as well.
This is a perfect example of picture painting 1,000 words. It is now very much clearer exactly where we're going from, exactly where we're going to, and the important information about how we get there. Which is where you say the alternate contrast on the slightly less important pieces is good.
Right, that's kind of what I'm looking at here. So let's kind of get all that in here. The reason I'm spending so much time on this is because I'm going to take a picture of this and I'm going to put it in the code is what I'm going to do.
Excellent.
So that's why I'm working so hard here. And what else is here? I think there's one more, I feel like. Did I get apex Y? Apex Y is the Y position of the sprite minus the fall distance. So that's this guy right here. So I'm going to move this up here and call this apex Y. That's Y equals apex Y. All right. Let's take both of these guys, drop them down as well. And I think that's it. That's my picture I want to take. All right. Let me grab a background behind that. Send to back. All right. Copy over here in the code. Paste. Oh, look at that. The text is a little blocky. I don't like that. Let's do this instead. Let's go to Paint and paste it in there. And then we'll cut it from there. So paste, cut, and now come into the code and paste it. Better. Okay.
Better.
All right.
Yep.
So there we go. So we've got, that's kind of what's going on. So this is like a really great example of why is it sometimes useful to throw pictures inside of the code. And CodeRush lets you do that really easily. You just copy the picture and paste it in.
Well, there's a much bigger difference cognitively between flicking your eyes from a line of code to a picture that's in line with you versus alt-tabbing to an entirely different screen, which in this particular case, the color scheme is entirely different. So the brain has to refocus on all kinds of things and potentially loses the ability to concentrate on the important facts in front of it.
Yeah, I think you're right. I think it's definitely harder to do. So let's look at this, make sure we've got everything right. Let's review the code with this picture right here. So my fall distance px, let's look at that. That's equal to my condition height times, well, I'm going to actually say it looks more like 1.5 now. Is that right or not? No, wait. If this top is here, move it up 1.5. Yeah, it's 1.5. So this assumption was wrong to begin with. Okay? So that piece, already I've fixed that and cleaned it up. It's only going to drop 1.5 from up there. Okay, next. I still don't think that's going to get us closer. I think there's another problem. So fall distance, I'm gonna say check. That looks good to me. I'm just going to throw this comment out here when I checked a line of code that I think is correct. I think I'm going to get rid of fade in time right here. That's what I'm going to do. Look at that. The picture went away. That was interesting. All right. How did I do that? I commented out this line of code. Is it going to reproducible? Well, look at this. Hold on.
Let's jump as well.
Do a CodeRush issue here, kids. Take a look at this, kids. So I'm hitting the slash key here. And look at that. As I comment this line of code out, my picture disappeared. If I undo it, it's back. If I comment it out, just one, and then another one, and it's gone. It just took one. I wonder if any change will make it disappear. No. It really seems like it's the comment key that seems to be the key to that. All right, that's the issue. Yeah, look at that. All right. Let me mark this. Images just appear briefly in TypeScript when slash key is pressed. Yep. Sure looks like that's somewhat reproducible. All right, so let's put that out there. We're dog fooding CodeRush, kids. This is what we do.
We are.
So sometimes we see an issue and we're like, wait, what's going on? All right, so let me see what I want to do here. I wanted to get rid of fade in time, so I'm going to comment that out. And let's keep going down here. Let's see what else we're going to do. Scale, vertical thrust override.
So our apex is the next thing, our actual apex y, because that is a fixed point now. Is that correct based on that data?
You know what? I got another idea on this.
Yeah.
I think this might also be related to it. Let me just try those two. Okay.
Because we've already scaled the other piece, but we didn't scale the sprite's origin.
Yeah, and that is important. So let's go ahead and try that and see how that works with the refresh on it. So, nope, it's still too big. And we're out of sync. Scale sprite's origin. Why? Why? The scale should be the same on both of those. It should not matter. They should totally be in sync.
And yet they were in sync. So what we've done is actually thrown them off somehow.
Yeah, and I don't think it's scale. Let's take out scale for a second.
Unless we're applying it to not enough additional things. I'm not sure what that would mean.
Yeah, no, I'm with you on that. Maybe. See what we got. Yeah, it's. I think that scale is so. So the scale is. I want to undo that. I feel like this is right.
Right. In line 1194, you're multiplying scale by condition height, which is... Well, no, that's correct. No, that's fine. We're doing several multiplications, but they are all being redone when they need to be redone, as far as I can tell.
Yeah, this is a little like mind-blowing to me, that taking that origin and multiplying it by a scale is changing how things are working and where they're landing.
So fall distance is scaled. Apex is scaled.
What if we follow your suggestion, which is we say, okay, let's multiply to scale across the overall distance of things, is what I'm wondering. So what we do is we take scale. Let's see, does fall distance have scale multiplied? It does.
Yep.
But what if I take out scale here? Condition height.
At the moment, no scale. There's a below ground Y that has a scale still in it.
And then apex Y, we take apex Y and we multiply all of apex Y times the scale. I'm just playing with this idea. I don't know that it's going to work.
So we're reducing the number of places where we do the multiplication by doing the assembling first, then doing the multiplication.
Yeah, that's kind of what
So less places where mistake can be made.
Well, but also I'm changing the math on this too. I am actually multiplying by the scale here. And this is screen height plus condition height times scale. This one is okay. I'm okay with that one right there. Distance from below ground to apex Y, that's also good. That doesn't need to be multiplied by scale anymore.
Each component there has a scale.
Yeah, scale's been
built in.
Yeah. What's fall distance in pixels? That one is not multiplied by scale. I guess this is a good time. I can't see anything. Where's my code?
Welcome, Pudding. How's it going?
All right, I don't know. Let's play with that and see what's going on with that. Here we go. Here's the refresh. I just want this to work, to be honest. I'm like, I want to move on to new problems to solve.
Mm-hmm.
This one's just going to be like, it's even worse. What is going on? Distance from below ground. How do we get so time to apex in milliseconds?
What is the pixels to meters doing? What scale is that basing it on?
It's on this right here. Pixels per meter is 50.
Okay.
So 50 pixels per 1 meter is what's going on there.
This is very strange.
Isn't it? It's like going in the opposite direction of what I'm expecting it to go with. We know scale's coming in at a negative number, or I mean at a number less than 1. And so the apex Y distance should be totally dropping.
We're no longer scaling sprite's origin Y on line 1202. Lower down. there. So we've got it on below ground Y from a previous calculation, but the sprites.origin Y isn't being scaled.
Yeah, I also took out the scaling on the other one too, right here. Sprite Y is equal to below ground Y minus the sprite's origin Y.
But back on 1191, we are multiplying origin Y into our scaled equation on that line. So we're scaling origin Y in one place, but not in another.
Yeah, no, I get that.
If you remove it, obviously that's, yeah. Okay.
I don't know what's, look, this is me. I'm like, let's poke until we see something that gives us an idea of what's happening.
Why not?
Yeah, not any better. It's worse, and it's worse. It's worse by, yeah, I'm back to my magic height factor as an option to fix this. It's kind of what I'm looking at here. This move to multiply this piece by the scale. Nope, that I'm going to undo. I'm going to start undoing a bunch of this stuff. Go back to where we were.
You've got a bunch of console logs in there that we haven't looked at the results of. Do we have any guesstimates what we think that should be, kind of valid figures?
Yeah, let me get a refresh on it right here so we can see it, and then we can go look at the log there. The other thing that's interesting is notice how thick the glow is when this first comes up. It's as if it's getting as if the glows are not being removed, is what it looks like to me. I haven't quite figured that out. So anyway, this is better.
That is better. What did you do to adjust?
I just rolled back the code, and I kind of want to come in and just be like, I could further roll it back to here, right? The magic number. I know, you're laughing, aren't you? I told you I didn't want to go here. There you go.
Pudding's asking, what are we trying to do? Well, we have our little diagram at the top there. We're basically trying to throw a tile from underground, immediately underground, into the air to a known apex position such that it has to fall, I think at this stage, 1.5 tiles before hitting the ground. Now, admittedly, it then goes underground and, we haven't yet stopped it. But the idea is that we're going to throw it into the first position of a stack. And then later other things will also throw onto that stack.
Yeah, the problem is our math is wrong. This 1.5 should determine how far above, but we have to throw in this magic height factor here, which is dumb, and it doesn't make sense. We're trying to throw it this much higher than when it lands. Now, part of what makes this hard to mentally track is this idea of anchors, and this thing is anchored in the bottom right, which means when I say I want it to be at this position, X and Y, it moves the bottom right to that position. Also making it difficult is the glow behind it. The glow has a different anchor, but that because it's bigger sprite, but it gets it to line up. So we've got the glows staying together, which was a little tricky. If we get the math wrong, the glows go apart. But what's not seeming to work is we're not moving. Our throw distance is much higher. Like if I change this back to a 1, and I refresh it, look at how high this thing goes above the 1.5 frames. It's much higher than what we're calculating, so I'm trying to figure that out, right? That's going up like about 4 or 5 times.
So essentially we're throwing the bottom right-hand corner of the tile. So we should expect, we're throwing it to, ideally, a height of 1.5 tiles.
Yep.
Yeah?
That's what we should be
doing.
doing.
And that's 2, possibly 3 tiles will fit underneath where that's going to.
Yeah. The other thing that makes this hard to track is we've also got a scale. We're actually running this at about, a smaller percentage of the scale. I don't want it to go that high. Yeah, that's why I've got this magic height factor thing in here to allow me to just change it to make it work. But I also don't know what
we rig. Sorry, Mark. What happens if we rig the scale to be 1? So we have bigger tiles, I'm sure.
Oh, that's a great idea.
It doesn't distort as many things.
No, that's a really great idea. Let's do that. That's coming in. That's right here.
Mm-hmm.
So we're going to just say let scale is equal to 1, and I'm going to comment this right there. Okay.
Just experimentally, like.
No, it's a great idea. Great suggestion. I love it. Let's see, because if that all of a sudden starts to work, then we know where to focus. The problem is on the scale.
Mm-hmm.
Nope.
No, it's still definitely too high. But that, on the upside, suggests that the scale, whilst maybe a factor, is not the main problem.
Yeah, I think you're right. I'm 100% on board with that. Scale is definitely not the problem.
I'm going to say 2 to 2.5 tiles fits in there.
Yeah, let's keep going.
So we wanted 1.5. Something else is out by that much. So we've got a 1.5 times our condition height. Our condition height at this point is definitely still 102, right?
Yeah, 102 times 1.5 is going to be 150. That's our fall distance. So this plus 150 is about 250 pixels. So fxy should be about 250, right?
Mm-hmm.
250. Am I getting that right? The fall distance.
No, that's 150.
150, but apex y is going to be on top of this distance here. So, well, that's assuming we're going from 0 up.
But that's the apex of the bottom right still, though.
Yep, I'm with you. I'm 100% with you on that. Let's look at this. Fall distance px. So fall distance px here. Pixels to meters. Get the drop time. We've got the drop time to land.
So Pudding's asking what condition height is. These are, the tile itself is our condition, so whether you are blinded or whatever. So the height of the iconography, which is in this case 102 pixels when we're not scaling it.
Yeah,
so
it's that thing right
that's
there.
going to something like, I don't know, 200 plus pixels, 250.
Yeah, it's going too high.
But 250 is what you said you were hoping it would. This is what I don't quite follow. So the apex is the sprite y, which comes from where? Minus the fall distance. I think the fall distance is around 150. Is that right?
Yeah, that's what I think as well.
Okay.
That should be 150. That means that my total distance up here, so I get what I get. I got to get my apex y, and I got to subtract from that, or I got to take my below ground minus the apex y. My below ground y is, oh, you know what we're not incorporating in the below ground y is the origin y of the sprites piece, I think. Is that right? Screen height plus condition height times scale. Well, actually, maybe that doesn't really matter because that's my distance from below ground to apex is there, and I'm using that to get my total drop time. And then I'm using my final velocity on that total drop time to see what my throw velocity should be. Yeah, it's the logic here seems like upon review, at least on some of the review pieces, it looks correct to me. The potential argument here is like what's going on here on this. Let's try something else. Let's try add condition. Where's my bottom edge y? Let's say bottom edge y. Let's take it. Let's move it 500 pixels up and just see what happens. Does everything still seem relative or not? What's my problem here? Bottom edge y is a constant. Oh, okay, let's throw it up there. It's 500, so we're taking about halfway up the screen. Do we start seeing things get really crazy, or is it still about the same? Why does the bottom edge y?
I want to say that's even larger because the start it appears and then goes considerably higher.
I would agree with that. So the question is, the bottom edge y, that's going to be the y of that piece, of that sprite. So that's our final position right there. We've got the data there. Apex y. Did you try hard coding with numbers yet? No, not yet, Pudding. Not really. Hold on. There's my y. There's my origin offset for that y. My apex y is these two added together minus the fall distance in pixels. That looks good. Apex Y, that's the Y position. Below ground Y. Am I not? What's interesting, below ground Y is the screen height plus condition height times scale. That's my below ground Y. What's interesting is it's starting in the middle of the screen, but we're very clearly setting its Y position here.
So we're setting the sprite Y position, but only after we've used the sprite Y position to calculate the apex. Mind you, that's fine because the apex isn't going to move. That is a valid thing to do.
Yeah. Yeah, I'm just moving it because when the X and Y coming in are the X and Y where we want it to be. So I'm now saying it should be below ground. The below ground Y here is screen height, which is 1080 plus the condition. This should show up. This Y position should be below screen. And yet when we do it now with the new adjustment, it's starting in the middle of the screen.
Which is, 500 pixels higher based on where we said to start, but it is going much higher.
Hold on.
After that.
This might be related to the problem. Because this is a moving object, I think I need to... there's a different call. I don't want to set Y is equal to this. Oh man, that's really the way that's adjusting right up there. I don't want to set Y equal to this. There's something in Sprite and I forget what it is. It's like just moved or something like that. Moved. Just moved, an animated element. Elements.moved. Just moved a element. So element.move, delta X and Y. No, I'm looking for something that messes with start X and Y. The reason why is because start X and Y are used in the math, in the physics. See, there it is right there. Mm-hmm. We need to change that. Start X and Y. Got a couple ways to solve it. Calling change direction calls changing velocity. I think what I want to do, let me see if I got any other calls to this. Clear ease point. Clear ease point could do it. The constructor, yeah, because we're starting at a different place and we're changing it. This is, I think, maybe the problem, Roy. Yeah. This may be the problem. That's why it's starting from, looks like it's starting from above the screen instead of down below. If we put it down below with that velocity, it might actually end up where we want it to be. That could be the problem. So let's do this. Let's create something new. Let's create something called just moved. Like this. Or let's just call change velocity. We're just going to call change velocity. Okay? Let's do that. Mm-hmm. We've already got it in there. Okay. So we're going to come down here and we're going to say sprite.changeVelocity, and we're going to give it 0 for the X and throw velocity Y for the Y, and we'll give it the current time right now as the time that'll go and take. Let's see if we get any better there. Okay?
Okay.
So let's do that, and let's say refresh. Now I have a feeling this is going to be better. Let's see what we got. Better. Now, it looks like it's not better, but remember I said what happens when I want to start at 500 off the bottom? Okay, so let's go back up and change that. Where was that? We're going to have to do a tab index reference on, we're calling it right up here. The Y position, I think
there it is.
There it is. Thanks. Okay, so there. We're going to restore that back to there. We've still got a scale of 102. Let's do it now. I think this is feeling like this could totally be the solution. Yeah, there you go.
That's better.
That looks like 1.5.
1.5 of a tile, yeah. I could buy that. So now we can vary the scale back to what we wanted, and you said originally 2.5 tiles.
All right, I'm
Could
glad
mess with that if you wanted.
glad we went down that path. All right, isn't that crazy? That it's like,
Yeah.
wait, oh, it's something inside. We have to call change velocity, not assign it directly. That's important to do. Okay, the next thing we need to do is get that scale, which is here. Get the scale back, and now let's watch that with the new scaled, and it should also work. I'm glad that the math that we thought was right was still right.
Yeah,
I'm good with that.
that looks all right.
Yeah, it's closer. And it's coming from the bottom below screen now, right? Before we saw it coming from above screen. Okay, all right. Good, let's clear up the, clear up our console logs. Don't need a fade in time anymore. Total travel time, looks like we need that now to figure out when to stop it. So I'm gonna do this, set timeout. My timeout handler is going to be condition landed, is what I'll call it, I think. And the timeout is going to be the total travel time, which should be in milliseconds. Like that. I want to change this to say milliseconds at the end as well. So I'm doing a good thing here. Let's change this. Might as well do it, right, as a good developer. Screen height and pixels as well. And I don't need to do that for the Y positions because the Y is actually just that piece. Now I need this. Condition landed. And I want to say this dot condition landed dot bind this. And we want to pass in any additional arguments here. So I think I'm just going to say pass in the sprite. Okay. So then we come in here, sprite. And now what I want to do is I want to say sprite dot change velocity 0,0, and I want to say sprite dot vertical thrust override is equal to 0 as well. What's wrong with my change? Oh, I need a PFN here. PFN for performance now. And there's something else I need here that I'm trying to remember what I need. I had it in my head a second ago. Oh, I want to set sprite dot, I want to say sprite dot data as condition state, I think. And set that equal to do a let. Do that. Then I want to say, hey, if condition state, then I want to say sprite.x is equal to condition state.final x, and do the same for the y, like that. And I think that's it. I might have to do, I forget if I'm going to have to do math here or not to add the origin x for the sprites, but that I think has a shot of working. Let's give it a try here. Flame Creation is here with a roar, roar. Welcome, Flame Creations. I'm going to match your roar with some roars.
Fair play. That works.
There you go. How you doing, buddy? Glad you're here with us. We're just trying to do some math, that's all. Let's see if we can come in here, go into conditions, bring up... oh, notice, look at the glow. So the glow we're not removing for some reason, it looks like, in this new world. Also, I'm hitting conditions now, and nothing is happening.
Coding Gorilla says he thinks we're going to get exceptions. Maybe that's what's happening. Have we got some null reference logic going on, or...?
Well, I'm not sure. We must have an exception here. What does he say right here? Should apex, since you're offsetting from the bottom of the top.
That was a little while ago whilst we were trying to figure out the previous bug. Right. I'm not sure that's... Oh, we're not passing parameters to condition landed. Is
right
that
here.
not how the set timeout works with the final piece there?
I think that's correct. Isn't that it? Arguments. But we should see this anyway before that timeout occurs. I don't think that's the problem. I guess I can do it and refresh it. Let's just see if that was the problem. I feel like I've got another problem here that slipped by me. Yeah, look, they're working again now. Sorry, I said, yeah, look, but you know what? The problem is maybe here in the call to set timeout itself. But that all looks good. That looks good. This looks good to me. Something's wrong. Let's go. Let's bring it up and let's see what the problem is in console log.
Mm-hmm.
I think, whoops, that's the wrong one. I went front overlay. Okay. There's the refresh. Hitting a button. No problems. Interesting. So on the live stream, we're seeing the old code working because I haven't refreshed it yet.
Yeah.
But on the one back here, we're just seeing a lot of glows coming up. It's as if the timeout's completely wrong. The travel time's completely wrong is what it looks like. And it's interrupting it and coming right on in here with the timeout and the sprite proxy. I guess we could throw out what that travel time is. Let's come over here, refresh it, refresh the data, and hit a button.
1.6.
That's in milliseconds. Oh, travel time is in seconds. I forgot that. Hold on. Travel time, hold on. Get drop time, this guy.
Mm-hmm.
That's coming out with in seconds.
Oh, okay.
Here you go. All time units will be in seconds. Hold on. No. Second. What is that? All right. I think I want to do a rename. Is what I think I want to do. But let's see if I can do that or not. Let's see.
Can you maybe add a second variation that returns, that value times 1,000 and thus gives you the milliseconds? So when you see this next time, you go physics dot and you get 2 get drops. You're not going to make the mistake of picking the wrong one.
Kids, I'm reporting a potential code rush issue there. Visual Studio became unresponsive and then shut down completely. Rory, send me an email on this one when we get it in here. I need to include the activity log in this as well. Let's bring it back up. Let me put my issue out, get it into the chat room. VS became unresponsive. I don't think this is us. After error logged to activity log .xml and then crashed. Okay, that's my issue. Flame Creation is asking, how is his best buddy Fred? Fred, can you answer that question? Are you good? You're best buddies with Flame Creations, Fred? Really? Well, like, I thought I was your best friend. Okay. Your second best friend? A guy you know? Okay. All right, Fred. All right. Let's see. I wanted to go into physics. Let's see if it's reproducible. Because I was a little worried about this, but let's go ahead and try it. F2 to rename. I'm hitting F2. Maybe I've got, maybe it thinks I'm undoing. Let me hit function lock and try again. There it is. Get drop time in seconds. Let's do that. Get final velocity, get displacement. Let's do get displacement in meters. And get drop time with velocity. And get drop time in seconds with velocity. Get final velocity meters per second. I know, they're longer, but that's what I want to do.
Nice and clear though.
Yeah, it is. And so that also is going to hopefully prevent future issues with what we just encountered. So let's see. I want to go to, hold on, just 2 quick issues here I can fix. And was it where was it? Conditions. Update player conditions. Do you have to go, Rory? You putting the sound down?
I kind of do.
Okay.
Yeah.
Well,
So, you know.
you always
sad for
help
me,
us through the
but
tough stuff. I appreciate that.
For the rest of you, on the other hand. I know how this works.
All these dance moves are my own, 100% copyrighted, Mark Miller.
Mhm.
Welcome. Welcome to the dance portion of the show. We dance where we dance for about another hour or two, and then we wait till Ray comes back and helps us write code tomorrow.
Okay, bud. We'll see you tomorrow.
Cody Gorilla says, damn, is it 1 player already? Sorry. I got Fred. You're right. You're going to help me out, right, Fred? Fred, come on, Fred. All right. Okay, so we don't need this. We do need to figure out get drop time in seconds. So this is going to be drop time to land seconds. Sweet. And then that means this is going to be multiplied by 1,000. Good. I think that's going to fix it. Come serve the day again. Come save the day again soon, says Pudding. I'm feeling like that's got a shot of it. Let's refresh. Way better when the math works like you want it to work. Let's go find those buttons. Here we go. Okay, it's stopping higher than I want it to stop. It's like it's stopping at the apex and not the second part. Time to apex. This is my problem here. All right, we'll get there. We're almost there. Time to apex in seconds. And this is going to be times 1,000 as well. Maybe let's pull this out and put parens around this guy right here. Okay, try again. Boom. Good. Not bad. Really not bad. Where's my prone button? Let's turn that off. Turn off fatigued. Turn off deafened. Petrified. Paralyzed. Invisible. Incapacitated. Grappled. Whoops. Where's frightened? There's frightened. Fatigued. Charmed. Get all of these undone. Okay, here we go. So here comes up. Boom. That's not bad. It kind of stops suddenly. There's no bounce. Whoa, that one looked like it dropped lower than the other one behind it by a lot. What's going on? Why isn't that working? Let's look at change velocity a second. It is changing my start X and Y. I think that's my problem, is what I think it is. I think I need to do the call to change velocity afterwards, and I think it'll stop at the right spot. That's what I think will happen. Let's try that. One more refresh. Refresh the data. Nice. Nice. Good. All right, so slowly getting there. I want a clicking sound when it lands, a little like that. It's not bad. Cool. Now we can change this 1.5 to get our fall distance here and change that up a little bit. Let's create a constant for that. Whoops. QN is my template. Fall distance factor. Let's make that equal to 1. Number of, or as a percentage of the tile. Height. Yeah, so we were struggling earlier on this, trying to get the trying to get this to work, and once we figured it out, the problem was not in this code, which was I was super appreciative of, because this code seemed to all make sense to us. So that's kind of what was happening earlier. So let's do this. It should now that change I just made should mean that it only goes 1 tile above its before it lands. Yeah. Good. Let's do it again. Let's make it 0.7 and refresh that. Good. Good. Now let's give it a horizontal thrust. Let's work on that. So this one's a little easier to calculate here, but it'll give it a nice curve as it comes in and lands. So I want to say sprite.x is equal to, let's maybe make a constant here. It's going to be our horizontal travel distance, px, whoops, px is equal to, let's make it 3 times condition height times the scale, something like that. And I suppose I should go with condition width, even though they're the same. Maybe not. Let's do this. Condition edge length, condition size. I like that. Length, condition length. It's a square. This is going to be just times scale right there. So my horizontal travel distance is going to be 3 of those condition pieces. So that means my x is going to go to the left by the horizontal travel distance. Then I need to calculate my velocity, which is going to be something close to this in look. That's going to be my x. And velocity is equal to distance divided by time. So I think I'm going to say, let's convert everything to meters here. Physics.pixels to meters. That distance divided by time, which is, where is it? Travel time ms. Total travel time in milliseconds. I need to get that to. What do I have? Do I have something that'll already do this? Get final velocity meters per second. I think we could call that. And pass in no thrust to it, 0 thrust. So the time is here. Initial velocity is 0. Acceleration is, oh no, that's not going to work, is it? Nope, 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 that's not, that's expecting thrust. Okay, back to where I was then. All right, so I've got pixels and meters by total travel time. I want to turn this into seconds. So I'm going to divide that by 1,000 right there. That's my meters per second. And is my velocity? Yeah, my velocity is in meters per second. So I think that's correct. And then now in my change velocity, I'm going to put this in here. And that could give us the arc we're looking for. There's the refresh. Here's the button press. Okay. That's the arc. I want to, it's not bad. I want to change that. Let's say horizontal travel factor. And I'm going to make that equal to maybe just 1.2. So whatever the size of that thing is, I'm going to multiply it by that. So it's going to be smaller. Let's refresh. Okay, I'm good. All right. That's step one. And that was like the easy part, it seems. I'm just seeing what these are and removing them. Okay, not bad. I want to change things up a bit. I want to change the velocity. I want to create an acceleration factor, and I want to like double it up right here. Let's also say, let's create another one here. So that's right there, meters per second. So if I double up the gravity, it's going to move and snap in faster. That's what I'm looking for here. Okay, see what we got. Better. Yeah, I like it. Okay. Yeah, I'm just going to tweak it down a little bit. Like that. So, we'll try that one, see how that one works. Okay, next we have to track how many are in the stack. That's a little tricky. I think I want something like this. Existing stack height. Get stack height. Passing in player ID. Then we're going to take existing stack height and add it in to this guy. Or maybe better, take this constant. I don't think it's used anywhere else. Yeah, just move it down here. and not actually add it. I want to subtract it. All right, so let's implement get stack height. Then what we want to do is go through all our condition sprites. And we want to check to see let's see, what do we want to get? We want to get conditions.data. Sorry, conditions of I. Data as a condition state. I'm going to just follow up because I'm noticing the image is blinking. This is like a follow-up to the previous issue that I talked about earlier. Just want to notice as I'm writing code, watch the image on screen as I'm making changes. Watch that. This can be conditions.sprites.length. Then we're going to come in here, conditions.sprites I.data. Okay, good, as condition state. So then we're going to say we need a new variable type condition state. If that exists, and condition state dot player ID is equal to player ID, then I think we're going to say I need to have one more check on condition state. Stacked like this. I'm going to come back up here in a second. Condition state dot stacked is equal to true. Okay, so that's going to mean it's landed. Because otherwise, if it's moving, it's not going to be. Should it be part of it? So I'm going to assume that when we're constructing one of these, it's thrown. Is that fair to do always? I think it might be. All right, so now we're going to come back. So now we're going to say, hey, if condition state, and this is equal to the player ID, and condition state dot thrown, or condition state dot stacked, then we're going to say, let's see, we'll create a num stacked is equal to 0. We're going to increment it right here. And then at the end, we're going to say return num stacked times this dot conditions dot what is it, height, sprites height, times the scale. And we got to figure out the scale. Somewhere in this world we have the scale decided. Is it already passed in here? It looks like it is. So let's just continue to pass that all the way in. Scale is passed in there. Is that Jetsam coming in? Nice, Jetsam.
He's in the house.
Jetsam's like, hey, you look like you're deep in concentration. Let's fix that. Greetings, buddy. Welcome. Okay, let's see. Let's get rid of these underlines here that we don't like. Okay, so the player IDs matched and it's thrown or stacked. We're good. I need to change thrown to false in our timer. Here it is. So I need those two lines there. And then later when we remove it, we're going to have to remove it. We're going to have to, because especially we have an animation out, so it's still going to be in the sprite stack, but it's no longer going to be part of the official stack. That's going to allow us to just smash the buttons and have them all still work. That's what my hope is, at least. That's what we're trying for there. I think this might work. So let's see what we get. Oh, nice. Oh, nice. That's really nice. Looks like I got one removed. And I bet I've got one doubled up over there somewhere in that list there. So now we need to make it so when we remove one, the remaining ones are removed as well. That was really fun. Let's take all of these, get rid of them all. Did I get rid of all of them? I've got blinded up there still. So one more time, here we go. 1, 2, 3, 4, 5, 6, 7. Looks like I got rid of one. And so we need to, obviously when we take one out, we need to make the other ones land and fall. Yeah, I'm pretty good with that. Yeah, I like that. That animation is really nice. Yeah. The rest doesn't make any sense without the other pieces going back into place. But that plus sound effects, click, click, click. I think it's going to look cool and sound and feel cool. How you doing, baby?
I'm not asking for your wallet.
Okay.
But your son is.
No, I'm not. I don't want to.
You son of a great, awesome guy with the wallet. Families getting a wallet. They come to get the wallet. I'm the keeper of the money, apparently.
Do we have parchment paper? Maybe.
Yeah.
Grappled, fatigued. Yeah. Boom, 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 boom. Yeah, I like it. It looks good. Coding Gorilla says, seems like if you throw another condition while a condition is still thrown, they land on each other. That's not happening now, unless you said that from before. Sorry if I missed that from earlier. That looks like it's working now. If you saw anything, it's because I maybe hit a button twice. But watch this. I'm going to hit a whole bunch of buttons, 1, 2, 3, 4, 5, like this. They land on each other. Now, that's it. I just hit them like that. Now, if you see anything that looks wrong, it's because I'm either removing one along the way. Like if I double up on one of these, let me undo them a second. If I double up on, I'm going to double up on paralyzed. I'm going to hit it twice. So I'm going to go, oh, so maybe it's when you throw the same one twice. Yeah. If I double up on it, what happens? Watch. I'll go 1, 2, 3, 4, 5, 6, 7. And now you see what happens is as it's coming up, it counts the one that's removing as still being in there. Then it takes it out and it's gone. And the next one says, where am I going? And so it lands on top. That will be fixed once we fix the removing. You can tell it's here because look at the glow is so much higher contrast than down here. It's like thicker. And that's what's going on here with poisons. So in fact, if I get rid of poisons, you should see one right behind it, probably petrified. Let's see. Yeah, there's petrified right behind it. So see what's going on? Okay, cool. Cool, cool, cool. I give you a thumbs up. Fred, you got a thumbs up for us? Fred says thumbs up. He's with us as well. All right, so next we've got to remove them and drop the stack pieces down. That's the next thing. And, you know, as with everything, I got to figure this whole thing out. By the way, we've been doing this only with my incapacitated, or with my conditions rather. But all these conditions work across the board here. So if we were to come in and say, for example, go into Fred and say, Fred is charmed, that's what his looks like. Uh-oh. Uh-oh. Uh-oh, what's going on? Oh. It's my parens here. That's what I need. That's the problem with Fred. Hold on, let's do it again. We'll duplicate and verify we fix that. Fred caught it. Good job, Fred. All right, so let's go. All right, cool. So I refreshed, hit the button, and then it just threw these out here. Let's get rid of Fred's, get rid of Charmed. Now bring Fred's in again. There, start at the bottom. So Fred can stack up as well. Yeah, I love the natural feel of that, right? As we're moving all the way up, right? The math is awesome, right? We're giving it that, and we've got parameters on it that we can tweak. Like we say, well, maybe it's going a little too high before it drops down. We might drop that down a little bit. But there's something about it I really, really love. And this is like, I love when we get something that I imagine and we actually get it working, and I'm like, oh, that's nice. So this determines on what the fall distance is right here. I'm going to change it to like 0.5. So it's going to get a little closer to it. And let's refresh it. Send the data over. I'm going to hit one of the buttons. Sweet. It's really nice. Let's bring in Miles's conditions here next. Yeah, it's nice. I like it. Yeah, something super cool about that. So it just goes about half of a tile above it. I'm hearing kids screaming nearby. Yeah, super satisfying.
Awesome!
Yeah, it's nice. Deafened, incapacitated, prone, and poisoned. And so here I'm going to just hit them all for Miles. Here we go. It's also cool because this is coming off of the Stream Deck. And, you know, I'm just hitting these, which means the chat message is going through, seeing the chat message, and then responding to it. So very, very cool. Let's undo these. I'll do them in reverse order so it doesn't look so goofy like they're just standing up in space like that. Get rid of the ones for Fred too. Who's screaming? I think you're asking. Mr. Smooth says that is very awesome. Yeah, something really nice about it. I like it. Yeah, it's funny too because I was thinking, here's what I want it to be. I want it to look like this, and charmed. There we go. And I kept thinking about it, and I was like, also had a debate like with myself, like, do I really want to do this? Do I want to take the effort to do it? But I think the answer is absolutely. I'm glad I did so far, right? This is where I want to be. I want these things popping up and down. I want them to look very much alive, interesting, like somebody is throwing something from down below and popping it up. That's what I want. I love that. All right, next. So we have a couple more things to do. Maybe it's a good idea to make a note of these things that we want to do here. Let's get rid of invisible, incapacitated there. Let's make some notes. So for conditions, under conditions, we have a couple more sub things we have to do, subcategories we need to do. We need to drop stack above when we lose a condition. We need to move stack left or right in response to nameplate width changing. And we need to scale stack up and down in response to, whoops, available space changing. So those are the three things we have to do. Right now, I'm going to work on this one next. Drop stack above when we lose a condition. So that's next. And I'm thinking I might save these two for tomorrow. That's what I'm thinking about. So let's see if we can get the drop stack working. All right. So prepare condition for entrance. That's for add condition. So in remove condition, here's where we want to take it out. And I think, all right, let's go look at what remove. So notice we're removed by player ID and frame index. We're coming in here. We're finding it. We're checking to see if the data is matching. And here's where we're actually removing the sprite. I think I want to change this to this dot remove condition. I'll change this to remove condition. And I want to say remove condition, and I want to pass in sprite and my condition data, my condition state data. And I think I want to pass in this too. That will allow us to search through the other sprites to see which ones are above it. So I'm going to do that. What's wrong with condition state? Oh shoot, I've already got a remove condition. Dang, dang, dang. Something like that, maybe. Now, at the start of the show, Codebase Alpha was suggesting, hey, what if you had like an explosion of teddy bears or something like that? And we actually found some animation that we thought we might be able to use for it. I think I'm not going to add that animation yet, but it might be something I do tomorrow. Is what I think I might do. We found some like confetti explosions. All right, so this should make no change at all in what's happening. But what I want to do is I now want to say, I'm going to do a for loop on this is what I want to do. Let's do this, sprites.length, and then we're going to say, I want to have an array of, I want to grab a bunch of sprites that are above it is what I want to do. So I'm trying to figure out what's above it. Okay. And I think what I want to do is I want to create a an array of these sprite proxies, call them sprites above, sprites above, right, like this. And what's going on here? You want me to be constant? Okay, then I want to do a check here that says, hey, if sprites dot sprites of I dot y is less than sprite.y, it's above it. But I also need to see if it's stacked or not. if it's thrown, what if I have one thrown and I take one out? Yeah, if it's thrown, I got to work with it too. But if it's stacked or thrown, either of those situations, we need to get its condition data. So we're going to say, let's do this. Okay, so here's my condition state. You have condition state. Yeah, I need something there too. So we're going to say sprites above dot push, and we're going to pass in the test sprite. We also know that we need to check to see thrown. Then I need to figure out where I need to drop it to. So I'm basically, all I'm doing here is just collecting my sprites above is what I'm doing. I'm going to extract this. So that's going to give me those sprites above it. And I think I want to sort these as well. How do I sort an array? I don't remember. I don't know if I've done this before, to be honest. Let's go find that out in TypeScript and JavaScript. Cool. Okay, so it looks like it is. What was the example? Sort. S1, S2 for my two sprites. You're gonna need an extra set of parens in there, is that right? Yep. I think that's what I'm looking for. That's, I think, the code. I think that's going to work. Either that or it's, I got to swap these two. But I think that's going to give me the sprites above. Just double check. Are we checking the... we're not. We need to get the existing player number as well. That creates a new instance of the array. Oh, thank you. Coding Gorilla, I think you may have saved us from a bug that would have taken a while to figure it out. Or I could just do this. Like that. We need to check to make sure that we need parens around this. And condition state, maybe I'll throw this on the next line. If conditions, this compare state dot player ID is equal to condition state dot player ID, then we found the same player ID in the stack, in which case it's good and qualifies. This should have actually been here. Maybe this should be moved up. Okay. All right. There's my sort. So there's my get sprites above. All right. If sprites above is greater than 0 and they're sorted now, I need to move them down to where this sprite was. So this sprite is, oh, we need the scale though. We need to take the scale. Okay. Okay, so there's my scale coming in. And now I think I just want to do that easing animation and bring all that down. All right. Okay, so if these are sorted in the right order, what do we have? Ease, PFN, that's my start time. My from X is going to be this sprite's existing. Let's do this. And then we're going to go from sprite dot X and sprite dot Y. The 2X is going to be sprite dot X again. And the 2Y is going to be sprite dot Y. Maybe we'll say new Y. And the time span is probably going to be about 400 milliseconds. So we're just going to do an ease. from one position to another. And if I get the order right, I want to basically go from the bottom to the top, and I may have got the order wrong, so I'll have to reverse it. If I got the order wrong, we'll see the top ones travel down really quickly and the bottom ones travel kind of slowly. But
Fix it!
I'll fix it. Okay, I will. You're just waiting for me to say that? Hold on. Did I miss anything in the chat room? Or did I do that? I can't see where I did it either. I don't see the chat room triggering that. Yeah, my chat room is empty in terms of last thing I have from Coding Gorilla was that creates a new instance of the array, I think. Fix it. Oh, there we go. Nope. Pudding just typed it in afterwards. I don't see evidence of anything, a button I hit or anything like that. It wasn't me? Yeah. I must have done it. How did I do that? Oh. I'm not sure. Oh, you know what I might have done? I might have clicked the window to do it, is what it looks like. Because it wasn't on my Stream Deck either. Okay. While I'm here, let's get rid of that chat back panel. Okay. That's funny. Yeah, Fred? Fred? Did you do that, Fred? All right. So we got to calculate this new y. So the new y that we need to bring in from the piece we're leaving. Remove sprite. So this is the sprite that's leaving here. So I need to say this sprite.y, I think, to pass it in. I've got a couple I thinks in this, is what I have. And then I think this is going to be my new y right here. Oh my God, I got scared. It says text it. Was it really loud? Probably was really loud. My apologies for that. I got to balance all of these. All right, so then we're going to say new y plus equals sprites above dot, oh shoot, it's not what I need. I need the height too. So we need one more thing in here. Sprites dot sprite height, pass that in there. Sprite height. Okay, so that's going to be plus that sprite height times scale. I'm gonna multiply it on the outside. It's a little more efficient. I don't know if that's going to work or not. Let's see what happens. There's a couple places where I wasn't sure, and I was thinking, that could go wrong here. See what happens here. Yeah, some sort of sound effect we need as this thing comes in. All right, let's take out invisible. Why did it drop all the way down? Let's take out sleep. Stun goes all the way down to the bottom. Okay, so if we take it to the very bottom, it seems to work. And there's charm that was stuck in there from behind. So let's do it. 1, 2, 3, 4, 5, 6. If I take out blinded, oh no, it does not work at all. All right, so we got some debugging to do. Oh man, it's a mess. Incapacitated. Oh, is this my problem? That I think is my problem. Let's try again. I think we're going to get better results this time. Okay, 1, 2, 3, 4, 5. All right, good. Let's take out paralyzed. What happened? What? How did things get just moved around like that? That's a little bit weird.
That worked!
Not really at all. Hold on. Let's see what we got here. Frightened, take that away. Yeah, so there is a swapping. The swapping that's happening is indicating that the sort order is reversed. Watch this. When I take out petrified, watch the others. I think they're going to look like they flip. Yeah, that's feeling like that's an issue. So, get sprites above here. I think this is going to change that swapping order. Let's refresh that. Okay, let's take out fatigued. That looks like it's working, at least for the ones on front. Let's take out invisible. Whoa, it kind of went out and came back. I'm a little stunned by that. That doesn't make sense to me. What's going on? I got to think about this. Charmed, take out charmed. Take out poisoned. Poison should just be fine. It's the only one there. Let's add a bunch. Let's take out charmed and deafened and fatigued fast. 1, 2, 3. Oh. Oh, because the new Y position. The new Y is part of the reason it stopped at the wrong spot here is because the new Y position is wrong. The new Y position is getting it from the, where's my new Y? Here. It's getting it from this, but I really need to get the sprites below. I need something like this. I need to say stack height below is equal to this dot get stack height below. Like that. Then my Y position is going to be, where we're going to is going to be my stack height below. I think it's just that. A new number. Who dis? Now it's stuck. We still don't know what's going on with the backgrounds though. The background, look at that. The background should be totally the same. So there's an interesting problem there with the backgrounds. Let's go find get sprites above and duplicate it and create this. Get stack height below. Sprites below. If they match and we're not stacked and not thrown, and then we want to say, well, if the test sprite Y is greater than sprites Y, then the sprite is below, closer to the bottom of the screen. Sprites below, we're going to add it. Then I think we just need dot length times, oh, and we're going to need to throw in something else like the oh, I think I know the problem with the glow. Hold on. Okay, next we need to see, what is it, sprites height? Sprite height, here we go. Get stack height. I'm going to change it to that. I think that's going to fix the glows separating each other's there. Then I want to pass in this times scale here. All right, so that's going to be the third parameter I add in to get stack height below. That is going to be the scaled condition height, like that. And then we're going to say the sprites below length is equal to scaled condition height times how many sprites we have below. I think that's going to improve the situation. Let's see if it's better or worse. Refresh, refresh, and let's throw something up. Take out grappled. That's unusual. I was not expecting that. Also, it did not seem to, did it help these or not with regards to the glow? Frightened? Why is it going up and not down? My sprites below check. Get sprite height below I think is not working. Blinded. What's going on with my get stack sprites above, get stack height below? How are we using this? Yeah, I think we need to say 1080 minus that. Still something's off, but let's see what we got with this now. Take out incapacitated. Seem to get no, the stack height of 0 in there. Yeah, it's not quite right. Charmed. Why is it dropping so far? The bottom was also going down too low. Yeah, no, I noticed that, Coding Gorilla. It's down too low for sure. Yeah, it's kind of a mess. And also look at deafened. That's a little crazy. Wait, that just seemed to work. Let me try getting rid of fatigued. That works. Grappled. Frightened is coming off the top. Let's try stunned. Trying to understand sleep. Restrained. So it's kind of working, it appears. depending on how far it's got to drop. Let's try invisible, so it's got to drop 2. Let's try petrified, so it's going to drop 3. Turned out quite nice, the status effects. Yeah, it's not bad. Dropping 3 seems to work. Poison, that's the bottom one. And then it goes off screen. Paralyzed, incapacitated, unconscious. Let's go back and see what's going on here. Let's put in 1, 2, 3, 4, 5. What's my problem here? I'm trying to figure out which one it thinks is on the bottom. Frightened just went away and came back. It looked like. No, it wasn't. It was paralyzed. Yeah, this doesn't look good. This part's not great. Shoot, it still thinks there's one somewhere here on the bottom. What is it that you think is on the bottom? Has Guy asked any recommendation for sites or articles for help getting into TypeScript? Welcome, Arhus Guy. I'll tell you, this is how we did it. Well, first of all, Stack Overflow is excellent for answering any kind of questions that you have on TypeScript. I also use this one. Use this at the beginning to try to teach me. Those are the main ones that I kind of picked up. I did not do anything else other than that, just saying, but just starting out, going in and creating an application. And that's what I've been doing. So pretty much self-taught, but using those two sources primarily. Those are the two that I would throw out at you there. If you're not already familiar with StackOverflow.com, it's a great resource for answering developer questions. Anybody else have any suggestions out there for RSky? So there's, what language are you coming from? That's a great question. I'm just going to hit each one of these buttons so until I see frightened drop. Oh, that was frightened. Hold on. Grappled. Not grappled underneath. Not incapacitated. Not invisible. Not paralyzed. Not petrified. Prone. It was prone. And so prone is there, and now frightened is there. I've taken them both down, and now we're back to 0. Okay. Wow. Okay. So I just wanted to get to this test case here. I wanted to get a bunch of these up, and I wanted to say, well, let's see. If we take invisible out, that should work. We've seen that drop 1. Oh, it did not. Paralyzed out. Oh, we've got this weird thing happening again, where the one we're taking out is actually below the other one behind it. So let's take out charmed. Let's take out frightened. Let's take out prone, actually. They all kind of stack up correctly, except for the bottom one is down just a little bit too much. Last night, almost time for bed. RS Guy says, most efficient in C#. Well, my experience in C#, I thought, made the transition easier to go to TypeScript. That's what I thought. Let's look at fatigued. Why are they going too low? We've got like couple problems here we're trying to solve here. Incapacitated, deafened, blinded. Let's bring them back up again. Nope, we got one extra on screen. I'm pressing each one, waiting for the drop to occur to see which one was the extra on screen. It was frightened. See that? Sometimes it works, right? Let's see, getting rid of restrained. Drops 3 from down. So TypeScript is very familiar to C#. This might help a bit. What you got? Oh, yeah. I think that's actually, so look at Coding Gorilla. Ask where are you coming from and gets an article for transitions for where you're coming from. Great job, Coding Gorilla. Good job. High quality information there. What is that? Unconscious on the bottom? Yeah. So it's a little bit weird to me that sometimes the code works as written and other times it does not. I'm almost thinking I want to take a break and think about it, is what I think I want to do. But I kind of want to just play with this a little bit more. Blinded, that's on the bottom. Crank these up. Now I'm going to take out Charmed. Charmed did not do well. "5 days to get into TypeScript before you have to use it in a project." I can appreciate that. Removing the bottom one didn't work. Let's figure this out again. Let's take fatigued out. That works. Frightened out. Works. Grappled. That seems to work. With the exception of the fact that they're off by a bit. Incapacitated and then deafened. When there's something else behind it, we don't know what it is. See what happens when we remove Charmed. Nope, it's that other one is way down below is the problem. I think that's part of the problem that's happening. Let's go over to Miles and we'll start from scratch with Miles. Okay, we'll bring all those up. Let's get rid of Charmed. Charmed does not work, so the second one from the bottom does not work. Let's do the same with Fred. Take the blinded out, and I think that's going to fail as well, right? So we've got to be at least 2 up from the bottom. Let's go to Lady. Yeah, I'm 2. Let's take out Deafen, see if Deafen works. Deafen did not work either. Yeah, I think I'm kind of feeling taking a break is what I'm thinking and thinking about this. That's what I think I'm going to do. Overall today, not bad though. We've got the animations coming in. I'll go over to Little Cutie and we'll bring hers in. Got that nice, sweet animation coming in there in response to the button presses to add the conditions. We're working on removing the conditions. That's next. We'll be doing that tomorrow. Working on the animation, fixing whatever bug is happening to us today. Let's get you a let's get a raid going here. See who's out there. Oh, we're sending you to Bald Bearded Builder for sure. Thanks everybody for your help. Last Matt, good to see you. Coding Gorilla, Arhus guy. Nice for you to show up. Pudding, as usual, Mr. Smoopy, glad you showed up. Texas 2010, sorry for scaring you. Jetsam, anybody else I missed out there? Thanks so much for hanging out and helping us. We will see you kids tomorrow.